All right, guys. So this is day 6. So it's a 10 problem worksheet, 5 of them on circles, 5 of them on parabolas. So just to give you guys some additional exposure and practice, coming up, you'll do another worksheet for day 7 on hyperbolas and ellipses, and then we'll review together as a class, and then eventually test, potentially in class, most likely online. So yeah, let's get started. We're starting with circles, which are our favorites because they're super easy and straightforward because they have the least amount of items involved in it. It's just a center and just a radius. Circles don't get any more complex than that. So we want to remember our generic form. So we've got x minus h, y minus k squared equals the radius squared. Okay, so the good news is that a lot of our other equations will look like this. We know that h is always going to be with the x. We know the k is always going to be with the y. We know that the center is always HK, meaning you flip the signs. So if you're looking at the equation, flip the signs to get the center. If you're looking at the center, flip the signs to put them back in the equation. So if this is my equation, I've got x minus 1, y plus 4, which means my center is going to be, flip the signs, positive 1, negative 4. So I'm going to go ahead and go to positive 1, negative 4. And then I am going to find my radius. So if 9 is my radius squared, remember, take the square root of both sides, and my radius is 3. Oops, my radius is 3. So, like we did in class that one day, which seems like a million years ago, the easiest thing to do is just to go 3 in every direction. Looks like I already have one of them plotted. 3 to the right, 3 up, and 3 to the left. And then the hardest part is just to draw the circle. Hey, that's actually not that bad. So I'm proud of that one. I'm sticking with that. But yeah, easiest way to draw a circle. I know they kind of look a little square oriented when we sketch them like that, but totally fine with me if it looks like that. Number 2, given the graph, find the equation. So the two things that we need our center and we need our radius. And once we have those two things, we just throw them in the equation, easy peasy. Usually you can look at it and just kind of estimate where the center is. Usually you're good at feeling it out. You can check though, check and make sure it's equidistant in every direction. So 1, 2, 3, 4, 1, 2, 3, 4. Yep, looks good. 1, 2, 3, 4. And 1, 2, 3, 4. So that's how you can confirm that you have the center if you're worried that your brain is just a little off and you couldn't find that middle dot easy enough. But yeah, in doing so, we found our center. So it looks like the center is at 4, 0. And then from counting and making sure you're at the center, we should have figured out that our radius is at 4. So we're going 4 out in each direction. So that's my radius 4. And so now I'm going to throw that in my equation. So we're going to do x minus 4, because I flipped the sign, plus just y squared equals 4 squared, which is 16. Guys, please, please, please remember, do not put plus 0 or minus 0. I know I made an announcement in the Google Classroom. I'm sorry, but I'm not going to edit the answer keys to accept that as a correct answer because you guys are in pre-calculus by now. You're going to calc next year, and we definitely don't do plus 0 or minus 0 in calc, okay? Those are redundant. Remember, we don't put coefficient ones in front of things. Those are all things that make our math more cluttered, and we don't need it, and we're smart enough to know that, yeah, we don't need it. Number 3. Super easy. They can't make it any harder. There's only 2 pieces of information. So if they don't give you the graph, they have to give you these 2 things. And so bam, it's so easy. We're just going to throw these into the equation. We're going to flip those signs. We're going to always have a plus sign in the middle. And then we're going to square that radius. Beautiful, easy breezy, beautiful cover girl. So now the last one is completing the square. Oh, no, just kidding. We're not there yet. Number 4. Okay, this one, please, please, please make sure you star, heart, sunshine this one and practice it. This was our number 1 most missed question on the target. So yeah, let's just really dive in and interpret what it's asking. So if we have the ends of the diameter of a circle, that means that the distance between the two is the diameter. And in no part of our equation do we want the diameter. We want the radius. So we want to know half that distance. And also that point that's halfway between the two is also going to conveniently be our center. So not only do I want this distance, I also want this point right here. So if I want to find the point that's midway in between the two ends of the diameter, I'm going to find the midpoint to do so. So remember midpoint, what do? Add them together and divide by 2. And when you say add them together, that means add the x's together, divide by 2. That's going to give you your new x coordinate. Add the y's together and divide by 2, and that's going to give you your new y coordinate. So our center is going to be at -10, +1, okay? -1 plus -19 is -20, divided by 2 is -10. -3 plus 5 is +2, divided by 2 is 1. So that's my center, and now the radius is the distance from the center to either one of these points. It doesn't matter which one, because the radius going this way is the same thing as the radius going that way. So it doesn't matter what distance you find. So yeah, I'm going to go ahead and I'm going to do this one just because the numbers are smaller. So I'm going to say the distance formula is the square root of, and actually I'm going to say not the distance, this is r, okay? The distance from the center to the ends of the diameter, that's my radius. So I'm just going to label it right there. So I'm going to say -10 minus -1 squared plus y minus my other y squared. Obviously, everything you guys do, you do at home, so you have the ability to look up any formulas that you need. That's the advantage to doing your work online. So if you don't know the distance formula, just Google it. This should give me the square root of -9 squared, which is 81, plus 4 squared, which is 16. And so now here's the cool thing about this is that normally we would go through and we would find the square root of that number. But if we're writing the equation, not solving for the radius, sorry, I totally have something stuck in my throat. If we're finding the radius, or we're finding the equation of the circle, we don't need the radius plane, we need the radius squared. So you can go ahead and stop right here before you throw that in a calculator and get some decimal answer, and you can just square both sides, because what that's going to do is it's going to cancel out these two things, and my radius squared is just going to be whatever was under the radical, which in this case is 97, okay? If that confuses you, then just go ahead and take the square root of that, find the radius, and then square it again. Hopefully it'll feel redundant that you did that, and it will remind you to just do it like this. But obviously whatever makes sense in your brain is whatever you should be doing. So then my final equation, I'm going to flip the sign for my center. Oh, sorry, that y totally looks like an x. And then it equals the radius squared, which in this case is just 97. So remember, midpoint first, that's your magic number. And then that number and any of the one of the 2 points that you started the problem with, okay? That's where you find your radius. And then the last one is completing the square. Hopefully you guys are getting really awesome at these, because every problem's got one like this. So I've seen you guys really grow and progress when you're turning in your targets on these. So let's change up the color and take a look. So the first thing that we're going to do is we're going to group our terms, and we're going to get rid of anything that doesn't have an x or a y term. So for that, it's going to look like x squared minus 10x. And then I'll put the y's together, y squared minus 4y. And then I'm adding 20 to both sides to make that go away. So I've got a positive 20 just hanging out over here. So now what I'm going to do is I'm going to open up these quadratic formulas, and I'm going to add that c term. Remember, you want that ax squared plus bx plus c term. You want that constant. In order to find that constant to perfectly be able to square your factors when you're done, you specifically want half of the b term squared. So over here, my b term is negative 10. Half of negative 10 is negative 5. Negative 5 squared is 25. So I'm going to say x squared minus 10x plus 25. Please, please, please remember that a negative number squared is always positive. It's always positive. If you're typing it in on your calculator and you're getting a negative number, you're doing it wrong, okay? Again, I'm sorry, I can't rotate my calculator, but please, if you're typing negative 5 squared like this and your calculator is giving you negative 5, your calculator is only as smart as you are, okay? So what's happening is order of operations. We know PEMDAS, E comes before multiplication, so it's squaring the 5 and then multiplying it by negative 1, because that's what a negative is. It's a negative 1 times whatever it is. So please, 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 if you want to square negative 5, that's totally fine, but use parentheses so that you square all of negative 5. Otherwise, it will do order of operations. Again, your calculator is only as smart as you are. So please, 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 please. Negative number squared has to be a positive number. So then we're going to run into that same thing for the y. My b term is negative 4. Half of negative 4 is negative 2. But negative 2 squared is positive 4. The reason that it's so important that you get those numbers right is because you need to add 25 to this side and you need to add 4 to this side. If you got a negative 25, that means you put a negative 25 on the right side and you're going to mess up that right side of your equation. So then lastly, change up my color again. I want to factor these polynomials. So again, it shouldn't take you long to figure out what it factors to because you picked that number. You shouldn't have to think really hard as to what multiplies to 25 and adds to negative 10 because you invented it. It's this number right here. It's half of b. So for my x term, it's going to be x minus 5 squared plus y minus 2 squared equals, oh, sorry, this should have been plus 25 plus 4. So that gives me 49. And then that's beautiful. That's an equation of a circle that you could totally be comfortable with. Usually you're going to know that you're right if that right side equals like a square number. If you're getting weird numbers with decimals, that's a sign to backtrack and look through your work. But yeah, for the most part with completing the squares on circle formulas, it's going to be a little indication that you got the problem right if it ends in a perfect square that you already know. So that's circles. Again, 1 through 3, super, super easy. 4, a little bit tricky with midpoint and distance. 5, a little bit trickier with completing the squares, but I am confident that you guys will be able to rock it out no matter what. Number 6 through 10 is going to be about ellipses. So let's chat about the generic forms of ellipses really quick, and then we'll dive in. So your h is always going to be with your x. Your k is always going to be with your y. I'm going to write this twice because as you've seen in your practice so far, you know that there's variations on this equation. So what you should be thinking about is what you already know and love, okay? You know parabolas are when x is squared. You totally know that. You know that x squared plus something is a parabola, and the parabolas that you have known and loved your whole life are parabolas that either open up or down, okay? So that means that when the x term is squared, your parabolas are either opening up or down, meaning that if you're looking at a graph and you see up or down, then you're going to make the choice to make the x term the one that gets squared, okay? And then on the other side of the equal sign is the 4p. So the squared and the 4p are never on the same side of the equal sign at the same time. And again, you can flip those two things. I don't necessarily remember what order it has it on the notes. But the 4p can be on the right side, the squared, or on the left side, the squared can be on the right. It doesn't really matter. Honestly, I just rewrite it whatever way like matches the equation that I'm looking at. That's kind of my only barometer when I'm setting these up. But then the other version of it over here, these are the parabolas that we're not as familiar with. This is when the parabolas open left or right. Sorry, these are really bad parabolas. And that means that the y term is squared. So when the y term is squared, you're going to open left or right, and that means the coefficient 4p is going to be on the other side of the equal sign, in this case with the x term. So we know that whether the parabola opens up or down comes down to 4p. If 4p is positive, it'll open up. If 4p is negative, it'll open down. And then over here, same thing. If 4p is positive, it'll open to the right. If 4p is negative, it'll open to the left. Okay, so those are some calls that you'll have to make when looking at a parabola and then writing the equation or given information. You're going to have to decide whether, whether 4p is positive or negative. So let's take a look at our first one. Again, I told you I just kind of write the equation based on what they give me so I can match up my terms. So I know that if y squared is the squared term, then the 4p is going to be over here with x. And so doing that helps me line up what my pieces are so I can see clearly that my center is going to be -4, -6. And then here, since there is no term 4p that I can see, that means that 4p equals 1. And it's important to set that equal to each other because I need to know what p is, not just 4p. P is the distance from the vertex to the focus and the vertex to the directrix. So I'm going to divide both sides by p. And that way I know before we begin that p equals 1/4 or 0.25, whatever your heart likes to think of it as. So what I'm going to do is I'm going to sketch really quickly. I'm going to start with my center. My center is at -4, -6. So that's right here. So now we have to decide right now, unfortunately, sorry, I keep saying center. It's the vertex, and I even wrote center. I'm so sorry. Parabolas don't have centers. They have vertices. Very sorry. So, unfortunately, the vertex does not tell us whether the parabola opens left, right, up, or down. Okay? It just tells us where that turning point of the parabola is. So we need to look at the equation and make decisions as to what direction it's going to open. So I look at the equation. I find that the squared term is on the y, which means my options are left or right if y is squared. And then to choose between left or right, I look at the 4p. And if the 4p is positive, then it's going to open to the right. If the 4p is negative, it's going to open to the left. And so looking at 4p, it's just 1. P is positive 1/4. So I know that this parabola is going to open to the right. So now, once I've established the direction that my parabola is open, now I know what direction to go, like P in each direction. So normally if the parabola opens up or down, then I would go up P distance, down P distance to find my focus and my directrix. If the parabola opens left and right, it's a y-oriented parabola, then I know that my distances of P are going to go left and right. So I'm going to go 1/4 to the right, which is just a little dot right there. And then I'm going to go 1/4 to the left. This is from something else. And so that gives me my focus and my directrix. So I'm going to say that my focus. So now depending on how your parabola is oriented, then your focus is either going to share the x coordinate or the y coordinate. So since my parabola is horizontally oriented, you can see that my focus shares the y coordinate, but the x coordinate changes. And so if I went 0.25 to the right, that means my x coordinate is like -3.75. but my y coordinate is still at -6 because you can see they're in line. And then my directrix is a line that's P behind the parabola. And so now that's an equation of a line. So that's either going to be x equals or y equals. And so I'm going to go ahead and even sketch that line through that point. And so that is a vertical line. So a vertical line is going to be x equals, and then whatever point on the x-axis it goes through, which in this case, since we went 0.25 to the left, it's going to be -4.25. Remember, the directrix, again, is the equation of a line. Some of you guys who had Miss Reidner last year, I know she teaches Hoy-Vux. And that tells you that a horizontal line has a slope of 0, and it's going to be written as y equals. And a vertical line has an undefined slope, and it's going to be x equals. When I was in pre-cal, when I was in high school, when we were talking about asymptotes, my teacher taught us hay vax, and he said to remember to get your vaccine for hay fever, and that was random then, and it's random now, but it helped me remember it after all these years. But basically it's the same thing. A horizontal asymptote is y equals, a vertical asymptote is x equals. Whichever one you remember, just that association of horizontal is a y equals, vertical is an x equals, horizontal y equals, vertical x equals. It's just a handy tip to have. I don't care which one you do, as long as you remember. And so this one also asks for the axis of symmetry. So the axis of symmetry is that line that if we were to fold the parabola in half, it would fold perfectly down the middle and line up with itself. The axis of symmetry is always going to be the opposite direction of the directrix. So you really only have to make one decision. Once you know the directrix is vertical and it's x equals, then you know that the axis of symmetry is going to be horizontal, and it is going to be y equals, and then it's y equals whatever y coordinate you would fold it in half through. And then we already have our sketch of the graph, and so that's it. I think number 6 is the easiest one because you do it graphically, and because of that, I'm going to do all the other problems similarly. I'm going to continue to draw a picture even when there isn't one, because instead of memorizing rules and thinking like, add P to the X coordinate, like I don't do any of that. I just see it all visually, and it's so much easier that way. So let's take a look at number 7. I'm like totally out of breath, like with this whole like quarantine thing and not teaching every day. Like teaching takes like so much like breath support that I have completely lost over the last 4 weeks. I'm like totally winded after I do these videos, but I do it for you guys, and you're so worth it, and I love you guys, and so yeah, I would do anything for you. So here's my sketch of the graph. This is gonna help me keep my orientation of everything straight, and get my x coordinate, y coordinates correct, my asymptotes, not asymptotes, axis of symmetry, and directrix, all good. So my vertex is at 0, -8. So 0, -8. And my focus is at 9/2, -8. If you're not a fraction person, because you're like, what the heck is 9/2? Just type it in your calculator. Usually that helps, like plotting it on the graph. So this is at 4.5, but -8. So this is enough information to write the transformational form of the parabola, because, like I said, the vertex doesn't tell us the orientation of it. It won't tell you up, down, left, or right, but we know that the focus, and again, this goes back to when I was in pre-cal. I remember a lot from that year. My teacher was really cool. He always told us that the focus is the serial. Okay, so if you think of your parabola as the bowl, the focus is the serial. So the focus always needs to be inside the serial bowl. So just having those 2 points tells you how your parabola is oriented. And so knowing that the parabola opens right also answers the question of where the squared goes, and then it also answers the question of whether 4p is positive or negative. And so just those 2 pieces of information have given us so much, so we're going to use those to also find the distance p, and then we should be good to go. So we know that the distance P is the distance from the vertex to the focus. And so if this is 0 and the focus is at 4.5, then that means that distance P is 4.5. They made it really easy by making the one coordinate 0. And so for the equation, we don't need P, we need 4P. So that means I need to find out what 4 times 4.5 is, because that's 4P. And it looks like I'm going to plug 18 into my equation when it asks for 4P. So I'm going to write the generic one. I've got x minus h, and I've got y minus k. If you notice, I always start out writing my equations like that with no anything, and then I go back and I put the things where I need them to be. So I know that the parabola is left and right, so I know that the y is going to be the squared one, which means the 4p is going to live over here with the x term. And then now I just go through and plug in what I know. So 4p is 18. X minus h is 0, so it's just going to be x squared. Again, please, no plus 0, no minus 0. We're smarter than that. We don't need to do that. And then y, we're going to flip the sign on that. And voila, that's my equation. That's everything I need. The y squared tells me left to right. The positive tells me right. I've got the vertex that I need, and I can figure out my distance p by dividing 18 by 4. All right, number 8. Number 8, we're given the parabola, but we're not given anything else. We're not given a focus. We're not given a directrix. We're not given, well, I mean, we can see the axis of symmetry. So we're able to find that vertex. You could probably find it pretty easily. But we don't know what P is. We have no barometer for that. So what we're going to do actually, and I don't know if there was one of these on the notes, but we are going to plug in the vertex. So I've got x plus 6, flip the sign, y minus 1, flip the sign. And so now, I'm going to move this over because you'll see. So the parabola opens up, which means the x term is squared. And then the y is going to have the 4p term, which is what we don't know. So right now we can't solve for p because there's 3 variables in this equation. There's the x, there's the y, and the p, and we all know that we can only solve for a variable when it only has one variable. So, sorry, I'm looking at an email that came in. I'm distracted. So what we're going to do is we're going to take a coordinate that we can see on the graph as another x and y point. We don't want to plug the same x and y point in. We want to find a different one. So you can pick any point on the graph that you like. You can see there's some really easy visible ones to see. I've got this. Let's do the -4, +5 term. So I'm going to plug in -4 plus 6 squared equals 4p, 5 minus 1. This is going to give me +2 squared, which is 4, and 4p times 4. And so you don't have to solve all the way for p. We don't want to know what p is. We just want to know what 4p is so that we can plug it into our equation. And so I can divide both sides by 4, and 1 equals 4p. So it means that my equation is pretty much done. I've got x plus 6 squared, and then it's just going to be y minus 1 because 4p is 1. So again, please, 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 you do not need to write coefficient 1. Again, that's redundant. You just wouldn't see that 4p term, and you would assume and you would know that it's 1. And that's beautiful. And so yeah, we are good to move on to the next one. All right, this one's probably our crappiest one. I feel like the progression of these ones is the same thing as the circle one. Number 6 is the best, and then 7's okay, 8's okay, 9's kind of tricky, and then 10's the completing the square one. But again, I firmly believe that everything is easier when you just think of it on a graph. So I'm going to borrow this line, make a graph here. Again, convert your fractions into decimals, especially for like seeing distances apart. I feel like our brains work better in decimals. If your brain works in fractions, then rock it out, live your best life. But this point is going to be 3, and then this is going to be 4.25, and then the directrix is going to be at 3.75. Okay, so I'm going to plot those on my graph. I'm going to try and be like specific and make the graph a little bit on a bigger scale. That way we can see the points. So if this is +3, this is, again, I'm going to try and make my scale a little bit bigger so that we can see what's going on. We'll call this up here 4.25. So that's where my focus is going to be. And then my directrix is going to be at 3.75. And again, it's a horizontal line. I know that because it's y equals. That means horizontal. So I'm going to do a dashed horizontal line through 3.75. So again, seeing it on a graph really helps me orient myself. I know that the vertex is going to be in between. Let's do a different color. I know that my vertex is going to be in between the focus and the directrix. The focus and the directrix make a sandwich around the vertex because you have the vertex and then you go P in each direction. So I know that my vertex is going to be right smack dab in the middle. And then again, I know that the focus is the serial and the parabola is the bowl. So I have to draw my bowl around the serial. Again, the parabola also never touches the directrix. So once you have that directrix line, it kind of forces the parabola to open in a certain direction, which is helpful. So now I have some answers. I know that x is going to be the squared term because it opens up. I know that p is going to be positive because it opens up. But I need to know that coordinate of the vertex so that I can A, plug the vertex into the equation, and B, know that distance p. So it's important to look at like the spread in distance. So the distance from 3.75 to 4.25 is a 0.5 spread, which means to find that middle point, I would go 0.25 up, and then that would be my smack dab in the middle term, which ends up working out really nicely for these numbers. Right in the middle of 3.75 and 4.25 is just 4 itself. So I know that my vertex is 3, 4. And so then I know that my P is the distance from the vertex to the focus or the vertex or the directrix. And so I know that that distance is a 0.25 distance. So P is 1/4 or 0.25, whatever makes your heart happy. And now we can throw those into the equation. So I've got x minus 3. I've got y minus 4. I know that the x term is going to be squared. And I know that 4p is going to be 4 times 0.25, which is the same thing as 1, which means I don't need to write anything here. If you've learned anything from this video, you've learned not to do plus or minus 0, and you've learned not to do coefficient 1. And this would wrap it up. This is, oops, sorry, my eraser was on. This is my full equation. X minus 3 squared equals y minus 4. And then lastly, we've got our complete the square. In the transformational form of a parabola, only one of the terms is squared. So you might think this one is easier. You might not. I don't know how you feel about these yet. But this one you only have to complete one square. But it does involve moving the y in the other term to the other side of the equal sign. And I know some of us got tripped up doing that on the target. So maybe we don't like these. But either way, I'm going to group. So I'm going to do 7x squared plus 112x. And then I'm going to subtract the y and add 444 to both sides. Sorry, I didn't mean to do that. So that's going to give me negative y plus. So now what I'm going to do is I am not going to complete the square if I have an a term, okay? I'm not going to complete the square if I have an a term. So I'm going to factor that -7 out. So I'm going to find out what 112 divided by -7 is. And I'm going to get -16. So this is something that maybe we've overlooked in the past, but the greatest common factor, the GCF, when you're pulling the same term out of two terms, always includes that negative. So while 112 isn't negative, I don't want to leave a -1 behind on this x term. I want it to be just a plain x, which means I have to take -7 out. And that's okay. You can divide 112 by -7, and that's what factoring out is. It's just dividing. So do 112 divided by -7, not just +7, and your answer will be -16. And that is the polynomial that we're going to complete the square with. So we're going to do half of -16 is -8, but -8 squared is +64. And now this was also a little bit tricky, and I definitely should have seen this coming, and I definitely should have sent out a little video or something to warn you guys, because I probably could have known we would have struggled on this. Because our practice with circles, we're really inclined to be like, okay, I added 64 to this side, so I'm going to add 64 to that side as well because I'm smart and I know what I'm doing. But what we tend to forget is the context in which you added this 64. So you've added this 64 in the safety of this parentheses, but this parentheses has this -7 coefficient applied to it, meaning that if I were to expand the left side, I would eventually distribute, oh crap, I didn't know I had the eraser on. I would eventually distribute this -7 to every term, meaning that what I truly added to the left side was -7 times 64. So I need to find out what -7 times 64 is and put that on the other side. So since it's a -7 and a +64, again, that means if I expanded this whole left side, there would be a -448 on the left side, which means there needs to be a -448 on the right side. So what I'm going to do is I'm going to say -7, and then again, I don't need to work hard to figure out this number because I invented it, so it's going to be half of the b term. So I've got x minus 8 squared equals -y plus 444 minus 48. I'm going to go ahead and combine those, and that's going to be, oops, it's not going to be positive anymore. 444 minus 48 is going to be -4. And so we're almost there. We're so close, but we know that there shouldn't be a coefficient in front of the squared term. So we're going to have to divide that out. And we know that we need to get rid of the negative in front of the y term, because in our generic form, we know that the y is plain. There's not a coefficient on it whatsoever. So what I'm going to do is I am going to factor that out first. I'm going to hold on to the -7 on this side yet, or for now. I'm going to factor out a -1. And so this is really obvious because the other term is negative. But again, we've seen on our targets, I'm just going to do a little example. Over here, if I was going to factor out this negative from the y, I would factor out that -1 and it would change the sign on the 3. Okay, I feel like you guys are more likely to get this one right because you see that negative. But you should pull that negative out to the front, and then you're going to have y plus 4. And then the last thing I would do is divide both sides by -7 to make it go away. And then I've got x minus 8 squared. And then here's what I would do just to like clean it up and really make it look like the most correct version that we're used to, is the negatives would cancel out, and I would just call this 1/7 as a coefficient, y plus 4. And that's what I'm looking for when I divide both sides by 7. Now that really, again, looks like what we're used to. You've got the squared on one side, and then that 1/7 is like that 4p coefficient. And that is your beautiful completing the square on vertex form. Yeah, so I miss you guys like crazy, and I can't wait to see you. I will zoom out right here and let you just like pause if you want an answer key. So yeah, pause right here if you want the first page, and then this is the second page. Again, sorry I sound so confused. I just got a phone call. Filming these videos is very distracting. So yeah, if you want to pause right here and get an answer key for the second page, that should be good. I will have a video for the next worksheet, and then the review we'll do live together because I miss your faces and I want you guys to be able to ask questions in real time and get answers and benefit the group by asking questions and just that general class feel. But yeah, I love you guys and I miss you so much. Be good, ask questions, and yeah.